You have an agent that works, the reasoning is clean, the tool calls fire correctly, the workflow handles edge cases you spent 3 weeks thinking through, you are 2 days from shipping, then someone on your team asks, what happens when the agent needs to pay for something and you realize you have no answer? This video is that answer, not a theoretical one. A practical, step-by-step breakdown of the payment infrastructure layer your agent needs before it touches production and exactly what breaks if you skip it. The bsuh.bearblog.dev post that surfaced on Hacker News this week makes the right call. Agents need control flow, not more prompts. The agent payment stack is the part of that control flow nobody has mapped yet. We are mapping it today. Stay through to section 6. That is where we walk through the specific architecture decision that costs builders the most time and money when they get it wrong. Every agent architecture diagram I have seen in the last 18 months has the same gap. There are nodes for reasoning, retrieval, tool use, sub-agent spawning, state management, and output formatting. There is rarely a node for agent settles a financial obligation. When there is, it points to a webhook that calls Stripe and the builder considers the problem solved. It is not solved. Here is the specific failure mode. Your agent completes a task that incurs a financial obligation, a contractor invoice, a SaaS usage fee, a token-based API call, a marketplace transaction. The agent has all the information it needs to execute the payment. Name, amount, destination, currency. Then it hits one of 4 walls. Wall 1, no wallet. The agent has no persistent, programmable financial identity. It has access to a human's payment credentials, which means every transaction requires human authentication. The autonomy breaks. Wall 2, wrong currency. The agent operates in USD, the contractor is in Nigeria, the invoice is in Naira. There is no path from the agent's wallet to a Naira-denominated payment without a manual FX step a human has to manage. Wall 3, no spend authorization layer. The agent can technically execute a payment, but there is nothing limiting it to the intended transaction. No per-call spending cap, no multi-sig requirement for amounts above a threshold, no audit log the operator can inspect. This is how you end up with the Grok $200K incident from this week's news, an agent with payment capability and no infrastructure around that capability. Wall 4, settlement latency. The agent completes a task in 3 seconds. The payment takes 2 to 3 days via ACH. The contractor does not consider the task complete. The agent has no mechanism to track settlement status and update its state accordingly. 4 walls. Any one of them breaks the workflow. Most production agents hit all 4. The agent post this week frames the debate correctly. Agents need control flow, not more prompts. This applies directly to payments. Builders who discover the payment gap first reach for the same wrong tool. They add a prompt. If you need to make a payment, ask the user for approval first. That is not a payment solution. That is a human approval gate disguised as a solution. The prompt approach has 3 failure modes in production. First, it scales at 0. Every payment creates a human interrupt. The moment you have an agent running 400 tasks per day, you have 400 payment approval requests hitting a human inbox. You have not built an autonomous agent. You have built a very complicated notification system. Second, it creates inconsistent authorization logic. Sometimes the human approves, sometimes they do not respond. The agent has no deterministic rule for what to do in either case. The state becomes unpredictable. Third, it does not solve the currency problem at all. Even if a human approves every payment, the infrastructure question of how a dollar-denominated agent wallet settles to a Naira, peso, or CD recipient remains entirely unsolved. Controlflow solves this. Specifically, define the payment node as a first-class component in the agent's execution graph. Give it deterministic inputs, amount, currency, destination, authorization tier, and deterministic outputs, success, failure, pending, escalate. Give it programmable spend limits that the operator sets at deployment time, not at runtime, and give it rails that actually reach the destination currency. That is an infrastructure problem. Build the infrastructure. Every agent payment stack built in 2025 and 2026 has an implicit assumption baked into its architecture. The recipient has a bank account, lives in a country where Stripe operates, and transacts in a major currency. That assumption excludes most of the world. Brazil's PIX system settled over $1 trillion in 2024. It is currently under pressure from Visa and MasterCard per Finextra this week, with the incumbents lobbying to reassert control over instant payment rails. Here is the fact that gets lost in that story. Whether PIX wins or Visa wins, an AI agent cannot authenticate to either system programmatically. Both require human-facing identity verification flows. Nigeria's NIBSS instant payment system processes 15 million transactions per day. An AI agent cannot open an NIBSS compliant account. The KYC flow requires a human applicant. Indonesia, Philippines, Kenya, Ghana, Bangladesh, every one of these markets has a payment infrastructure that works for humans and fails for agents. This is not a niche problem. The global majority of the people and businesses that AI agents will serve over the next decade are in these markets. If your agent payment stack only works where Stripe works, you have built infrastructure for 15% of the world and called it a solution. The first agent wallet that works in the global majority is the one that wins. Every other agent wallet assumes the user transacts in dollars and lives in a country where Stripe works. BananaCrystal does not make that assumption. This is the architectural claim worth writing into your system design documents today. Let me be specific. A production-ready agent payment stack has 5 components. Most builders ship with 2. The 3 they skip are the ones that cause incidents. Component 1, the agent wallet, a persistent programmable financial identity for the agent, not a human's credentials delegated to a bot. A wallet the agent owns, with a balance the operator funds, and a set of permissions the operator defines at deployment. USDC on a fast, low-cost settlement chain is the right instrument. Hedera settles in 3 to 5 seconds. That matches agent execution speed. ACH does not. Component 2, programmable spend controls. Operators set maximum per transaction amounts, daily spend caps, currency whitelist, and destination whitelist at deployment time. The agent cannot override these. Every payment attempt that exceeds a control parameter escalates to a human queue rather than executing. This is not a limitation on the agent's capability. It is the authorization layer that makes the capability safe to deploy. Component 3, multi-currency settlement. The agent's wallet holds USDC. The recipient may need Naira, Cedi, Peso, or Rupee. The stack requires a liquidity layer that executes the FX conversion at settlement time without a human managing the exchange. This is the layer most builders skip because they assume their agents will only pay USD-denominated recipients. They are wrong within 90 days of production. Component 4, settlement status as agent state. When the agent initiates a payment, the settlement status becomes a first-class state variable in the agent's execution context. The agent knows whether a payment is pending, confirmed, or failed. It updates downstream workflow state accordingly. Without this, the agent has no way to determine whether a task is actually complete. Component 5, a complete audit trail. Every payment the agent initiates, every authorization check, every escalation, every settlement confirmation, all of it logged, timestamped, and queryable. This is not optional in production. Operators need this for compliance, for debugging, and for the inevitable moment when an enterprise customer asks, "Show me every payment your agent made in the last 90 days." 2 of these components exist in most current agent stacks. The wallet, usually improperly implemented, and sometimes an audit log usually incomplete. The spend controls, the multi-currency layer, and the settlement status as state are consistently absent. Friday is the right day for this conversation because the practical question is, what do you actually build before your agent ships? Here is the sequence. Step 1. Instrument your agent's existing workflow and find every node where financial obligation could arise. Not just explicit payment calls, implicit ones too. API usage fees, token consumption charges, contractor task completions, marketplace purchases. Map every financial touchpoint in the execution graph before you write a line of payment code. Step 2. Define the authorization tiers. Not all payments are the same. A $3 API call and a $3,000 contractor invoice require different authorization logic. Define the thresholds now, not after an incident forces you to. Step 3. Choose your settlement instrument before you choose your payment provider. USDC on a fast settlement chain is the right starting point for agent payments. It settles in seconds, not days. It is programmable, it is interoperable across chains. Do not start with ACH and plan to migrate. The migration cost is higher than getting the instrument right at the start. Step 4. Test the global case on day 1. Take your agent's payment flow and route a test transaction to a recipient in Nigeria, Indonesia, or Brazil. Do it in week 1 of development, not week 8. The failure modes you discover will reshape your entire architecture. Discovering them in week 8 means 6 weeks of rework. Step 5. Treat settlement status as a first-class variable in your state schema. Add a payment status field to your agent's state object today. Wire it to your settlement layer's webhook. Write the branch logic that determines what the agent does when a payment is pending, confirmed, or failed. This is 3 hours of work that eliminates an entire category of production incidents. None of this requires a complete rebuild. These 5 steps map onto whatever agent framework you are already using. LangChain 0.3.30 shipped this week. The new release supports more granular tool state management, which makes the payment status integration cleaner than it was in 0.3.29. I said at the top that Section 6 is where we cover the decision that costs builders the most time and money when they get it wrong. Here it is. The decision is, do you build the agent payment layer as a tool call or as a native capability in the agent's execution environment? Most builders implement it as a tool call. The agent calls a payment function the same way it calls a search function or a database query. This feels clean. It is wrong for 2 reasons. First, payment tool calls have no natural mechanism for state persistence across agent restarts. If the agent crashes or is restarted while a payment is pending, the payment status is lost. The agent may initiate a duplicate payment on restart. In a tool call architecture, preventing this requires significant additional engineering that most teams do not do until after a duplicate payment incident in production. Second, payment tool calls do not participate in the agent's authorization model. The agent's reasoning layer can call the payment tool with any parameters it generates. There is no architectural boundary that enforces the spend controls the operator define. The controls exist in the tool's implementation, but the agent's reasoning layer does not know they exist. The Grok $200K incident is the production version of this failure. The right architecture treats payment capability as part of the agent's execution environment, a first-class, permissioned resource with its own authorization model, its own state persistence, and its own audit layer. The agent requests payment execution. The execution environment validates the request against the operator's defined controls. Only then does the payment proceed. This is not a philosophical distinction. It is the difference between a payment system that an enterprise will deploy and one they will reject after one security review. The agent economy is not waiting for better models. It is waiting for better infrastructure. Control flow is largely solved. Reasoning is largely solved. The payment node is the last load-bearing wall that has not been properly engineered, and it is the one that determines whether autonomous agents can operate at scale without constant human intervention. If you are building agent infrastructure today, build the payment layer correctly from the start. The 5 components are not optional features for a future roadmap. They are the foundation. All of the research behind this video goes into the Agent Payments Substack at agentpayments.substack.com. If you are building in this space, subscribe. It is daily, it is specific, and it is free. And if you want to see the payment infrastructure that handles the global majority case agents transacting in local currencies across markets, Stripe does not reach, visit bananacrystal.com. Subscribe if this was useful. The next video covers the specific failure modes in multi-agent payment flows. What happens when agent A instructs agent B to make a payment, and neither of them has a clear financial identity. That one goes deeper into architecture. See you there.